Hello, welcome to another tutorial. Today we will go over Freeport. Freeport Protocol is a flexible serial communication feature available on human-machine interfaces, HMIs, that allows users to define custom data exchanges between the HMI and external devices, e.g., PLCs, sensors, or proprietary hardware. Unlike pre-configured industrial protocols, e.g., Modbus, Profibus, Freeport does not enforce a specific data structure. Instead, it empowers developers to design their own communication logic by directly controlling the serial port's transmit and receive operations. Freeport is ideal for connecting devices that use non-standard or proprietary protocols, such as legacy machinery with unique communication requirements, or custom-built sensors or controllers lacking support for common protocols. It enables direct transmission and reception of hex or ASCII messages, giving developers full control over packet formatting, e.g., headers, footers, CRC checks, timing, e.g., delays between commands, and error detection, e.g., manual CRC or checksum calculations. Supporting RS-232, RS-485, 2-wire, 4-wire, and other serial modes, Freeport is adaptable to diverse hardware setups. Freeport operates through macro scripting on the HMI. Users write scripts to initialize the serial port, send custom commands, receive and parse responses from devices, handle data validation. To create Freeport, we will start by initializing the serial port. We will configure the serial port parameters so the HMI can communicate with external devices. Let's create a macro and select system functions on the right of the pop-up below read-write function. Use the setComParam function, and a set of directions will pop up below for you to adjust. Set the port number, baud rate, data bit, stop bit, check bit, communication mode, and return value. I will set it up to the default value. Compile and save. Go to the touchscreen and double-click. It will open up the window modifier, in which we will press the timer tab and add a timer to the window. In the trigger condition, select trigger when the window is open and also select in the end condition. Stop when specified count value reached. Now in the timer function tab, select macro and place the port initialize macro. Now, we will create another macro that sends hex messages. This will transmit a predefined hex command with a CRC checksum. In this code, we will create a buffer. Unsigned char sendbuff 12 concierge may 0 art defines an array of 12 characters initialized to 0. This buffer will hold the data to be sent. The buffer sendbuff is filled with specific hexadecimal values. Then, let's calculate and add CRC with this code. It calculates the cyclic redundancy check for the first 9 bytes of the buffer and adds the high and low bytes of the CRC to the buffer. Sending the buffer, out port 0. Send buff. 11 sends the first 11 bytes of the buffer through the specified port. Then, setmem copies the buffer to a memory location, and return 0 indicates the end of the function. Link this macro to a touchscreen button for manual triggering. We select component switch, then function key. A pop-up will come right up. Action will be press. Function setting will be execute macro. Function operations select the macro we just created and press OK. Label the button and press OK if no additional settings will be set. Then we will add the numeric value display. Go to Component and select Numeric Value Display. Add the appropriate address and address type. Select the 16-bit hexadecimal in the number format, and also click on leading 0. Display it on the project. Right, click on the component to multi-copy the numeric value display. To create the ASCII macro, which is to send a human-readable string, we start by defining an array of 100 characters. SendBuff, initialized to 0. We then use the sprintf function to copy the string into this array. Next, we send the contents of sendBuff using the outport function, specifying the port number as 0, the data to send as sendBuff, and the length of the data as starlen sendBuff. Finally, we set the memory for previewing the data on the screen with the setMem function, using sendBuff as the data. At LW100, at as the memory location, 0 as the starting position, and starlen sendBuff as the length of the data. This sequence of steps ensures that the string is properly prepared, sent, and displayed. Press OK, and now let's link to the UI, in which we will assign this macro to a button to trigger it. Same thing, create a function key and select the macro that we have. Next, we will create a character display and tag it with the appropriate address used for the send packet ASCII. Once that's in place, navigate to the character settings and select ASCII encoding. To create a script for receiving messages and reading incoming data from the serial port, we define an array recbuff of 100 unsigned characters initialized to 0 to store the received data. The import function reads data into the recbuff array, with parameters specifying the port number, buffer, number of bytes to read, and a timeout value. Finally, the setMem recbuff at LW0 at 0 starlen recbuff function writes the data from recbuff to the LW local word registers with parameters including the source buffer, destination register, starting index, and length of the data to be written. Create and link this to a component. Select a component switch and function key. Afterwards, add a text display for the receive packet. Now we can test this project. Let's download the project to the HMI. With this, we conclude today's video. Freeport is the go-to solution when off-the-shelf protocols fall short. It turns the HMI's serial port into a blank canvas, letting developers build custom communication bridges for virtually any device. Whether you're working with legacy systems, prototyping IoT solutions, or integrating proprietary hardware, Freeport provides the tools to make it happen.